Suppose you work for a vehicle safety foundation. Your job is to study owners' habits with regard to maintaining safe braking systems. You have obtained authority to randomly select vehicles undergoing emissions testing and do a brake system evaluation. A previous study indicated that 20% of all vehicles on the road have brakes that are excessively worn or are compromised in some other way. You are going to select 25 vehicles. Find the probability that exactly 6 have unsafe braking systems. So what we want to do is verify that all the criteria of the binomial experiment are met. The first criteria is that there are n independent trials. In other words, the outcome of one trial would have no effect on the outcome of the next trial. And what we're going to do is randomly select vehicles as they come in for emissions testing. We would have no reason to believe that any one vehicle would be more or less likely to have unsafe brakes than any other that's coming into this emissions testing station. So we do have n independent trials, and as a matter of fact, we have 25 independent trials. The next criteria is that the probability of a success is consistent from trial to trial. So let's do this. Let's identify what a success is by saying let x equal the number of cars with unsafe brakes. Okay, then a success would be finding a car with unsafe brakes, and then the probability would be consistent from trial to trial if it is known that 20% of all vehicles on the road have brakes that are excessively worn or are compromised in some other way. So that means then that P will be equal to 0.20. The next criteria is that we only have 2 possible outcomes, a success and a failure. And that's the case here. We're either going to have a success, finding a car with unsafe brakes, or a failure, which would be finding a car with a safe braking system. Now we have to detach the positive connotation of a success and the negative connotation of a failure when we're doing this. Obviously, it would seem like a success to have a car with safe brakes and a failure to have a car with unsafe brakes. But our study here is to find cars with unsafe brakes. So a success would be finding a car with unsafe brakes, and a failure would be to find a car with safe brakes. Now the formula for calculating a binomial probability is the probability that x takes on some value is n factorial over x factorial times n minus x factorial times p raised to the x times q raised to the n minus x. So the probability then that x would equal 6 would be 25 factorial over 6 factorial times 25 minus 6 factorial times 0.2 to the 6th power times 0.8 raised to the 19th power. Obviously, we're going to need a calculator of some sort to calculate this probability. This probability comes out to 0.1633 if we round to 4 decimal places. In the next video, we'll look at the tools that we will use for calculating these probabilities.